assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Right, when we look at a polyprotic acid, such as phosphoric acid, which is H3PO4, we know that there are multiple ionizations that can occur, right? So what we have here is H3PO4, the top line is the first ionization. And if we look that up, that would have a Ka1 value that we could find in a table in the book or online. When we look at the second ionization, right, we see that the H2PO4, which was produced in the first equation, ionizes again, and that would be considered our Ka2. So that's a separate equilibrium with a separate equilibrium constant. Now, when we actually go to figure out or calculate the molarity of our hydronium ion, right, what we find is that the only one that's really important usually is the first ionization, right? So the hydronium ion produced in our first equilibrium with Ka1, right? And that is because that is going to be the largest molarity, since our Ka1 values are typically going to be a stronger ionization, meaning they're going to give off more hydrogen. The Ka2, our second equilibrium constant, is typically a much smaller compound, a much smaller number, which means it produces less hydronium ion in solution. So when we actually calculate our hydronium ion, what we see is even if we do the math to figure out the second and possibly third ionizations for those hydronium ions, they're going to be so small that even if we add them on to our initial, our first ionization hydronium, they're going to be so negligible that when we look at sig figs, they actually round off and they don't make really any difference at all.